Thank you, Mr. Chairman. I am Giacomo Risitano of Messina University. I am a researcher in machine design. Okay, the title of my presentation is Fatigue Assessment by the Thermal Analysis during Tensile Test on Steel. There is in literature now a lot of papers about the thermal response of during a set test of the composites or of the steel. But there is not a study for the welded specimen during the study test, and we have used digital image correlation and thermographic technique. And after, the aim of our study is the application of thermographic methodology during the static tensile test and during the fatigue test to predict the fatigue limit of the steel. Okay. The infrared thermography was applied for the analysis of different material subject to different loading conditions. For example, knocked steel specimen or laminated composite under tensile static load, or short glass fiber reinforced during static and fatigue loading, or shape memory alloy, or sandwich under impact loading. Our investigation is not in during fatigue regime, but during static test, because the traditional method of fatigue assessment is extremely time consuming. But 20 years ago, a new method, a new thermographic method, a rapid thermographic method was proposed and there is the name is thermographic method. Okay, we want to predict the fatigue limit of the steel with during the static test. The material used in this study is S69012 steel. The static tensile tests were carried out with the Istrom machine with the cross-seed rate of 3 mm/minute. The DIC and the air camera have been used during all the tests. In this slide, we can see the stress-strain curve. The strain was evaluated by the DIC analysis at a distance of 5 mm from the center. This is in the slide the temporal evolution during the static test, and you can see for a base material. This is a thermal image, and this is for the welded joints. We can see that the air technique is able to predict the fracture zone if you can see the image, and it's with the right figure with the macro feed, you can see this. Okay, during the static test, a common engineering methods have the temporal surface have a free face. One approximately linear decrease, the thermoelastic effect. After, there is a deviance from linearity, and the third phase is a temperature increment until the failure. Okay, for us, the fixed deviation from linearity is exposed to correlate with the fatigue limit. In this slide, you can see the stress in the time and the surface temperature rise for the base material. We can see there is a deviation from the linearity of the thermoelastic effect for a stress of 390 megapascal. If we see for the welder joints, the same, but of course we have a different stress for 280. After, we have the fatigue limit predictor for base material was confirmed by the fatigue test carried out at 420 megapascal, which don't produce any failure effect after 2 million cycles. After we made the fatigue test with the same geometry, with the same material, with the loading ratio of 0.1 and the frequency of 10 Hz, and we have used, of course, the TR camera for the TM methodology. And we have plot the temperature increment versus the square of the stress maximum, and we can look for the fatigue limit with where the temperature, the increment of the temperature is 0. A summary of the results, we can see that for the static test for plasma material, we see an average value for 3 specimens of 390. After, with the TM fatigue test, average value for 3 specimens is 383 megapascal. After, we have made a fatigue test, and for 420 megapascal, we did not produce the specimen failure after 2 million cycles. Now we have made the same for the welder joint, and we see the average value for the static test on 3 specimens is 218, and when we make the thermographic methodology fatigue test, we see that there is 255 megapascal. In conclusion, the general marriage correlation thermographic technique was applied to this steel and on base material and welder joint during the static and fatigue test. We can see that the EF technique was able to predict the failure zone, the fracture zone, in the first stage. The thermographic methodology was applied to a new steel for us, no letter 2 present for this methodology, for base material and welder joint during static test. And we have compared the results of the fatigue limit with of the test of the static test and the fatigue test. Thank you for your kind attention.